Hi everyone, and thank you very much for joining me today for this session on data lakes, lakehouses, and data mesh. My goal today is to share with you how to build a modern data platform that suits your needs and helps you evolve from wherever you are in your current data journey. My name is Rada Stanic, and I'm a Principal Solutions Architect at AWS based in Sydney. The agenda for today is simple. We will start by explaining what it means to become a data-driven business. We will then spend some time covering core concepts such as data lake, lakehouse, or data domain as we call it sometimes, and finally data mesh. You will see how they all play a role in building a modern data platform on AWS. Next, we will dive deeper into architecture patterns for building data mesh on AWS, and finally, I will leave you with some recommendations on how you can best approach building a modern data platform for your own organization. So let's get started by defining what it really means to be a data-driven business. Firstly, I wanted to share with you some feedback that I hear from our customers on a daily basis. They tell us that they would like to share data more easily between their different lines of business while preserving their individual autonomy. It is that data sharing while keeping control of data access, security, and governance that appears to be the key point. Our customers also raise questions such as how can we treat data as a product? How do we move from monolithic architecture, which is slow to change, to a more distributed approach with greater agility? All these points have led us to create architecture patterns that allow our customers to focus on innovation rather than administering their data platforms. In light of this customer feedback, I think that there are three key attributes to consider when defining what it means to be a data-driven business. Firstly, a business is data-driven if its data platform is built so that data can be treated as a business asset and a product that can be shared across an entire organization. Secondly, data access must be democratized, and users should be able to access it freely in order to foster quick experimentation. And finally, a data platform must have unified and lightweight governance, which should allow for fine-grained access control and security. Our customers start their evolution towards data-driven business because they're trying to solve specific business problems, and we find that the most common ones are migration of legacy data warehouse to cloud, big data processing, real-time analytics, improving the customer experience through sentiment prediction, creation of personalized customer offers, fraud detection, and other machine learning-powered outcomes. Regardless of their specific business problem, they all ask for advice. Where should I start, and what should my strategic architecture be? Should I build a data lake or a lakehouse, or should I go with data mesh? Now, let's cover the core concepts and revisit what data lake, lakehouse, and data mesh are. So, how do we define a data lake? To me, it's best defined as a centralized repository that allows you to store all of your structured and unstructured data at any scale. You can store your data as is without having to first structure it. And then you can run different types of analytics, anything from dashboards and visualizations to big data processing, real-time analytics, and machine learning in order to achieve outcomes for your specific use cases. I have purposely used this illustration to depict evolution from data warehouse to data lake and then lakehouse. A data warehouse is essentially a database which is optimized to analyze relational data coming from transactional systems and line of business applications. The data structure and schema are defined in advance to optimize for fast SQL queries, where the results are typically used for operational reporting and analysis. Data is cleaned, enriched, and transformed so that it can act as a single source of truth that users can trust. A data lake is different because it stores relational data from line of business applications and non-relational data from mobile apps, IoT devices, and social media. The structure of the data or schema is not defined when the data is captured. This means that you can store all your data without careful design or the need to know what questions you might need answers for in the future. So you must be wondering then, what is a lakehouse? It is a pattern which allows you to connect your data lake, your data warehouse, and all your other purpose-built services, search, big data processing, into a coherent data domain architecture that is focused on minimizing data movement. As you will see today, this pattern will become a foundation for evolving your data platform towards data mesh, so please remember this. Since this is an architecture session, I will not be focusing on individual services, but I still wanted to give you a quick snapshot of the most common purpose-built tools that sit on the perimeter of any lakehouse data domain. You can use Amazon OpenSearch service for storing and analyzing large volumes of log data at a low cost. Amazon Athena allows you to perform federated and on-demand queries, or you can have a cloud data warehouse such as Redshift. For real-time streaming, we have services such as Kinesis or Managed Service for Kafka and Elastic MapReduce to help us perform big data processing at scale. To build your data domain lakehouse, you can choose just one or a combination of these services and end up with completely different lakehouse data domains for different lines of business within your enterprise. This kind of flexibility is really important. Okay, so we have seen the evolution from data warehouse to data lake and lakehouse, so by now you must be thinking, what's next? What's next is a data mesh, which can be best defined as an architecture pattern with two specific goals. The first goal is to organize your data platform around one or more data domains in order to deliver enterprise data products. The second goal is to support this concept of data producers and consumers from across the enterprise with a layer of lightweight governance. It may still feel unclear and abstract to you, so let me take you on a journey to explain why and how. To start with, we see that our customers have built or can build a data lake or lakehouse-based approach for a specific domain, and they can get all the benefits I mentioned earlier, such as minimizing data movement, use of purpose-built tools, cost reduction, and so on. However, when they feel the need to evolve further by sharing data between business units more freely while keeping their autonomy, it is time to start considering data mesh. What enterprises gain from data mesh is better agility, a more lightweight approach to policy enforcement, security entitlements, and identity management. The most significant outcome of data mesh is this concept of a data product that helps with scale, innovation, and collaboration while allowing lines of business to protect their autonomy. This diagram is just a better visual representation of how multiple domains aligned to multiple different lines of business, or LOBs as I'll call them from here on, come together into data mesh architecture. The beauty of this approach is that individual lakehouse data domains can be different for different LOBs. As an example, one LOB can only have big data processing platforms such as EMR, Another can have cloud data warehouse such as Redshift. And let's say the third lob can have visualization and search capabilities only. We stay true to the approach we have always advocated for, and that is to use the best tool for the job and only those tools needed for your specific use case. So by now, I hope you can see how we have evolved the architecture from a humble data lake to a domain-specific lakehouse, and how we can scale it even further with data mesh. Once again, please note here how each node in the mesh is a purpose-built data domain lakehouse. It really is an important point to keep in mind. I want to further visually represent this data mesh evolution from a single lakehouse data domain to a minimum of 2 data domains, which are consumer and a producer in this example. We are aiming to achieve some specific business outcomes here. Accelerate the independent delivery of business data domains as each domain becomes an independent entity. Increase data security within domains. Enable self-service of data product creation, discovery, and subscription across an entire organization. And finally, enable continuous and lightweight audit and governance. As always, we love to support any given pattern or architecture with a specific customer reference, and JP Morgan Chase is just one of many. They modernized their data platform by firstly evolving their monolithic data lake to a loosely coupled data architecture. Secondly, by focusing on data product creation across the enterprise. And lastly, by creating federated governance. This strategy resulted in cost savings and promoted data reuse across the entire enterprise, which are the key goals of data mesh. By now, I have mentioned the term data product several times, so let's look at an example of what it is. Most companies think of their data as a platform and not as a product, and that is a fundamental change that I am advocating for here. If I was to define it, I'd say that a data product is simply a broad, cohesive collection of related data, analytics, ML capabilities, all aligned to a specific use case and goal. For a lot of industries, including retail, travel, and financial services, this might be a Customer 360 capability, which must incorporate data from multiple lines of business to create a clear picture of the customer across the entire enterprise. And without something like data mesh, it would not be easy to achieve. More importantly, it would be difficult to keep evolving and enriching this data product that is Customer 360. So now, let's dive deeper into architecture patterns that allow us to create the concept of a data product and, in turn, data mesh. I wanted to start with the pattern that is familiar to many and the most likely starting point in any organization's data journey. If you look closer, you will see that this is a double click into a single data domain, which will effectively become a single node of our data mesh architecture. I already described this conceptually, but now we will look at it in more detail in a functional sense. Every data platform starts with a set of existing data sources, which could be S3 buckets, databases, applications, or file stores. From those sources, data is ingested into the lake, where we stick to the best practices of having 3 layers of raw, trusted, and refined data. We encrypt using KMS, govern and control access using IAM and lake formation, log using CloudWatch, and so on. We do all our ETL using Glue and orchestrate data using something like Managed Workflow for Apache Airflow. Finally, we have a serving layer, which can be anything from a cloud data warehouse such as Redshift, or NoSQL database such as DynamoDB or a notebook. This is purely dependent on the use case. These serving layers map to the appropriate consumer, which could be a dashboard of some sort, or a data scientist, data engineer, and so on. I mentioned that data domains are the nodes that make up a data mesh, and we often talk about these nodes as producer and consumer accounts. Data producers share one or more data products and make them discoverable through a common central catalog. That central catalog enables federated data governance, and you can maintain security and compliance across all the data domains or accounts without switching between individual accounts. Finally, data consumers can easily discover data and access the resource shares via APIs, as well as services that are enabled by those APIs. Let's zoom into an example of a data producer building a single data product. We are looking at a single account, and you can see in the blue outline that we have a data product account. In that account, you'll have something like an S3 bucket and various services used by the data product team to produce their data. That team makes their own choices of data pipeline for ingestion into S3. They own the actual buckets and are responsible for the life cycle of their data. That includes everything from SLA, stewardship, low-level security. When they are ready to share their data product, they catalog assets inside a central lake formation account to make them accessible by consumers and discoverable by other users inside the data mesh. Producers then use that central catalog to govern access to their data product, usually through something like lake formation, tag-based access control, and I'll talk about that soon. But for now, let's see how this might look in practice. Here I have a data product from Lob 1 and a data product from Lob 2. If the Lob 1 creates a table in lake formation called Table A, they can grant permissions to Lob 2. The lake formation will essentially create an alias to their table in Lob 2, and it will show up in the catalog. Lob 2 will then create a resource link within their catalog to point to the original table, Table A, so that the applications can reference it. Once that's done, that data product is shared with the users of Lob 2. Please note that you don't have to recreate anything. There is no ETL, there is no movement of data. All data is accessed directly from the original Lob 1 S3 bucket via lake formation. It is worth reiterating that all necessary data governance is still the responsibility of the data owner. Even though it's sitting in a central federated account, the data owner still owns their product, databases, and tables. They own the KMS keys and the permissions that authorize access via the lake formation. They own the tagging process and control which tags are attached to specific resources. Additionally, because everything is in a central account, data stewards and auditors have a central location where they can validate everything within the entire data mesh. There is no need to go to hundreds of different accounts to validate that everything is being shared properly. Similarly, consumers X and Y here have one central catalog they can use to discover and access datasets. Also, whether you are using IAM or SAML-based access or any other provider, you have a central method for accessing your data. Lake formation takes care of vending credentials and records to your end users and allows for fine-grained entitlements down to the column and row level. Finally, since metadata is in a central data catalog, you can search that metadata in one location. Now we'll look at the data consumer. Data consumers must first find the data, and that's where the central catalog comes in. Once they find a dataset they have permissions to see, they can request access to it. Once the producer grants access to it, the resource share is created and the end users can access their data. Once the data is granted to the consuming account, that account can use any engine compatible with lake formation to interface with the data, whether it is Athena, SageMaker, Redshift, EMR, QuickSight, Glue, or similar. The data consumer gets to choose how to interface with their data. It really is important to point out that they are not prescribed a method such as only JDBC or SQL. They can use any tool that is right for the job. Once our mesh expands to multiple consumers and producers, it starts to look something like this. You have a database in Lob 1, another one in Lob 2, and a third in Lob 3. Lob 1 is going to share table A, Lob 2 might share table B, and Lob 3 decides to share table C. Lob 1 can grant select permissions to consumers X, Y, and Z. Lob 2 might grant permissions to only consumers Y and Z. Finally, Lob 3 might just grant select access to consumer Z. Now, what's important here is that the data still resides in the producer's accounts. The actual databases and tables reside in that central data account and are not moving anywhere. Permissions are granted from the central account out into consumer accounts or to any other producer who needs to consume that data. And of course, we see through these permissions that consumer Z gets access to tables A, B, and C. Consumer Y gets tables A and B. And consumer X gets access to table A. Now we can simplify this process of permission grants by using lake formation tags. I can simply say data consumer X gets all data tagged with HR. Data consumer Y gets all data tagged IT. And when a data producer applies a tag, correct permissions are granted anywhere where that tag applies. With this process of tag-based access control, you really can make the data sharing process flow naturally in a way that makes business sense. It really is important to remember that all permissions will always go through lake formation, regardless of where your computational resources may be. Let's dive deeper on how data mesh patterns might look on AWS. We will first look at peer-to-peer and then the centralized option. Here we have a central data lake account with 3 buckets: raw, trusted, and refined. The first thing an end user is going to do is register the data lake location with lake formation. In our case, that means registering those 3 S3 buckets. This tells lake formation enabled engines to use lake formation permissions to access the data rather than using direct IAM access. The second step they will take is to populate the data catalog by using a Glue crawler. The crawler will create a table representation of the data in those buckets. The third step is to run ETL jobs to enrich, refine, and move data. They will also update the metadata for the existing tables and create new tables as necessary. The fourth step comes when they're ready to publish the data. At that point, they're going to create a database resource link from their account into the consumer account. They're also going to grant a share from the data lake account to the consumer account. Once in a consumer account, they will create a resource link pointing back to the original. Then, the consuming account data lake admin will grant IAM select or necessary permissions to the original users. Once a user has permissions in their IAM role, they can use any engine they need: Athena, Redshift, EMR, Glue. The process is very similar with a central governance account. The biggest difference is when you register a data lake location, that location is registered in the central account. When you create a table, it is also created in the central account, just as our databases are. The only difference is that now, when you create a database or table, it is shared back to the producing account. The key here is that there is no data in the data lake account. The catalog itself is empty except for resource links. Essentially, all resources, the tables and databases, reside in the central federated governance account. The rest of the process is the same as in the previous example. The ETL is performed to enrich and refine the data before permissions are granted from the central account to the consuming accounts. This pattern scales especially well with tag-based access control, allowing you to automatically apply permissions and grant them to the accounts and end users. Lake formations tags make this whole process incredibly automated for both producers and consumers as the new datasets become available. As promised in the beginning, I'd like to summarize the key points that I'd really like you to take away from this session. Firstly, a data lake is the starting point of your modern data platform on the cloud. You get to establish your foundation as infinitely scalable, cost-effective storage for all your data. Lakehouse is a pattern for building your specific data domain architectures while choosing the services you need, whether they're big data processing or cloud data warehouse and similar. Data Mesh builds on top of all of that, and it's a natural evolution of your modern data platform. It allows you to start treating data as a product, share, collaborate, and establish a self-service data platform while having lightweight governance and a strong security framework. And just when you think we're done, I also wanted to share some useful AWS and industry resources that I personally recommend you review to further extend your knowledge. Also, what better way is there to prove to yourself that you have really built your skills than getting a certification, especially a data specialty one? Please review our Skill Builder resources to continue your cloud journey. In the end, I wanted to thank you for choosing to watch this session. I hope you have learned something new that will encourage you to explore how to improve and build a modern data platform within your own organization. Please complete the session survey and let us know what you think, because your opinion really matters to us. Thank you.